Hi everyone, this is page 2 of the chapter 1 test review. So this will be the second page starting with problem number 9 and going down to number 17. Okay, so back up at number 9. Again, we're equation solving here. And a couple different approaches you could take to this next one. I would get rid of your fraction right off the bat. Actually, I would get rid of both of your fractions. So you've got a 3 over 10 and a 6 over 5. And so to clear fractions in an equation, I look for a number that both of the denominators, or all of the denominators if there's more than two fractions, look for a number that all of the denominators go into. And then in this case, 5 and 10 both go into 10. So I'm going to use 10 as my common denominator. Now, if you use, let's say, 50, that would work just fine. Okay, so 50 would work just as well, or 20, or any other number you could think of with 10 and 5. So I'm going to multiply everything by 10. And what's going to happen here, 10 times 3 divided by 10, those 10s are just going to cancel. Now, I do not need to multiply in here by 10, because this is being multiplied by this out here, and this has already been multiplied by 10. So it's like that 10 has already been distributed. But I do need to go over here and multiply by 10. Okay? And that'll be 6 divided by 5 times 10, or 60 over 5, which is 12. So now I have 3. I'm going to actually go off to the side here. 3 times t minus 20 equals, and then again, 10 times 6 is 60. 60 divided by 5 is 12. Okay. From here, and some of you may go ahead and distribute that 3. You're welcome to do that. There's nothing wrong with doing that. I'm actually going to move the 3. I'm going to divide by 3. Divide by 3. So this cancels. And now I'm left with t minus 20 equals 4. Move up here because I didn't give myself very much room. Next thing I would do is add 20 to each side. So then for my answer, I would end up with t equals 24. Okay, let's look at number 10. Let me give myself some more space here. The thing that might get tricky with number 10 is knowing what to do with that negative sign. Remember, it's not the 6a that's being distributed. This is not right in front of the parentheses. You're not distributing the 6a. You are distributing this negative sign there and there. So here's what that would look like. 4 equals 6a. All of that stays exactly the same. And then this is going to become a negative 2. Now it is not minus negative 2. It is just a negative 2. And then here we have a negative and a negative. So when I distribute that, that becomes a positive 2a. Now I can look for things that I can combine, like 6a and 2a. So now I have an equation that says, let's go over here, give myself a little space. Now I have 4 equals 8a, because 6 plus 2 is 8, minus 2. I've got all my variables on the right, so I'm going to move my other numbers to the left. I'm going to add 2. Whoops, I meant to do that in blue. Add 2, add 2. And I end up with 6 equals 8a. Let's divide by 8. Divide by 8. This one is going to be a little weird. 6 divided by 8 is 0.75. So I end up with 0.75 equals a. There's your final answer. Okay, similar thing going on in number 11 with that weird negative sign out front. I'm going to take that negative sign and distribute it inside the parentheses. Need more room. Go. So this is going to stay a 3. This negative is going to become a negative m. And then this is going to become a negative 2 equals 4m. So now I would combine the 3 and the negative 2. Now remember that 3 in front is a positive 3. So 3 minus 2 is 1. And then I still have a negative m equals 4m. Now I need to get all my m's to one side. So I would add an m and add an m. And so now my result looks like this. 1 equals 4m plus m is 5m. Oh, I'm giving you lots of fun fraction ones today. Divide by 5. Divide by 5. Again, I'm dividing by 5 because that's the number that's with the m. And I end up with 0.2 equal to m. Final answer. Okay. All right, number 12. I get a lot of questions on problems like number 12. Again, I would get rid of those fractions first. That's the first thing I would get rid of. So I would look at my new denominators, and I would look for something that they have in common, something that they would go into together. 2 and 3 both go into 6, so I'm going to take everything in the problem and multiply by 6. Okay. Now when I do that here, this is really going to be 6 times x divided by 2. So really the 6 and the 2 I'm going to end up dividing. So 6 divided by 2 is 3. So this is now a 3x. And here, 6 divided by 3 is 2. So this is now a 2x. Now the thing that people forget a lot is that you also have to multiply the 6 by the 10 and the 6 by the x. So 6 times 10 is 60, and 6 times the x on the end is 6x. If you forget those two, it's going to make your answer wrong. All right, I'm going to combine 3x and 2x because they're on the same side. So I get 5x plus 60 equals 6x. And then we want to try to get our x's together. Whoops. So I would subtract 5x and subtract 5x, and I end up with 60 equals x. Final answer. Okay, let's see. Let's scoot that up a little bit. 13. Solve for n in the formula. Okay, remember when I say solve for n, what I'm saying is you want to get n by itself, which means you need to move everything else away from n. Okay, so the first thing I would do with this one is get rid of the 4. Okay, this 4 needs to move, so I would subtract 4 and subtract 4. So now this side is going to say t minus 4 equals, don't lose track of that negative sign, that's a negative 5n. And then to get rid of that negative 5, I would divide by negative 5 and divide this whole thing by negative 5. So my final answer, and remember you do want to write a final answer, would be n equals t minus 4 divided by negative 5. That's not the prettiest way to write it, but I'll take it that way. Okay, I've zoomed us in a little bit on this next one. And this is asking us to solve the formula for h. What I want to point out is that we did this example together in class. We did it in our notes. I believe we may have done it on a homework assignment. I'm not positive about that. And now I'm asking you to do it again here. So I want you to start recognizing those patterns. If I'm asking you to do it that many times, it probably means you're going to see it again sometime. So if I want to solve for h, that means I want to leave h where it's at and move everything else away. So I always tell you to start with the fractions. So I would multiply by the reciprocal, which is 2. Multiply by the reciprocal, which is 2. And this is all one chunk. So when I multiply by 2 this one time, that takes care of everything. Okay? So now this is going to say 2a equals, that's gone, h times b1 plus b2. Now if I'm trying to get h by itself, really I need to get rid of this whole chunk. And that whole chunk in the parentheses is attached to the h with multiplication. So that means I can get rid of it with division. So I'm going to divide by b1 plus b2, which means I would divide here by b1 plus b2. So now this whole thing is gone, and my final answer would be h equals 2a over b1 plus b2. Now in your notes we also did this same example, but we solved for one of the bases. We solved for either b1 or b2. You may want to consider looking back at that example too, because that works a little bit differently. Okay, 15. Does the table below represent a function? Justify your answer. Well, remember the important thing about a function is, do any of the inputs, which are the x's, pair up with more than one of the outputs? And I see right here, -1 and -1. Okay. Here, -1 is paired up with 1. Here, -1 is paired up with -1. That makes it not a function. Okay. So for justifying your answer, you could just say -1 is paired up more than once. You do want to be specific. You don't want to just say the numbers repeat. But this is not a function because there are more than one of the -1 in the x's. Okay, what about number 16? The set of ordered pairs represent a function. Same idea. You're still looking at your x values. It's just that your x values are in these ordered pairs. So if I look at just my x values, none of those repeat. 1 is only matched up with 2. Whoops, didn't mean to do that. Meant to do that. 1 is only matched up with 2. 2 is only matched up with 3. 3 is only matched up with 4, and so on. So this is a function. Yes. And number 17. What numbers are not part of the domain? Okay. So remember what I'm asking. When I ask for domain, I am saying, what is x allowed to be? But remember, sometimes it's an easier question to ask, what is it not allowed to be? So look at where the x is located and think about, are there any issues there? X is located in the bottom of a fraction in this problem, and that bottom of the fraction cannot equal 0. Okay, so if it equals 0, that's bad. Actually, it's not allowed at all. Where's the bottom of my exclamation part? There it is. So I want to think about what numbers would go in for x there that would make that equal to 0. So if x squared were equal to, if x squared, jumping ahead of myself a little, x squared minus 25 were equal to 0, that would mean this x squared, let's do a different color, this x squared would have to equal 25, because 25 minus 25 gives me 0. So what number could I put in for x that would square to 25? Well, hopefully you come up with 5. But the one you might miss is -5, because -5 squared is also 25. So if I were to make x equal to 5 or x equal to -5, then this x squared would equal 25, and then I would have 25 minus 25, which is 0, and that's bad. Okay? So what I want to say for my domain, for my final answer here, is x is allowed to be almost anything. So I'm going to say all real numbers except 5 and -5. Okay, there's probably a better way to write that, but I'll take that. So really what you want to say is x is allowed to be anything, but it's not allowed to be 5 or -5, because both of those would give you a 0 on the bottom, and that's bad.